When dealing with industrial engines or heavy-duty machinery, one of the most vital, yet often underestimated, components is the fuel injection pump. Specifically, the 2644 P501, 047006003, 216, 9824, and 2,169,824 models have become essential for consistent performance in engines such as the Caterpillar 3056C and the Perkins 1106C or 1106CE60 TA. This component doesn't just push fuel. It's responsible for metering the precise amount of diesel required at the exact timing needed to ignite within the combustion chamber. Any deviation, whether in pressure, flow rate, or timing, can drastically affect engine output, efficiency, emissions, and longevity. Let's dig deeper into why this fuel injection pump matters, how it operates, what testing procedures to follow, installation best practices, common signs of failure, and how to ensure you're getting an authentic, high-quality part. These pumps are engineered with extreme precision. The internals consist of hardened steel components, including plungers, a rotor, and a control valve system. These elements are manufactured to tolerances measured in microns. The primary purpose is to deliver pressurized fuel to the injector nozzles at exact intervals based on engine load, RPM, and throttle input. Because the working environment is so intense, pressures upwards of 25,000 psi and extreme temperatures, material quality and build accuracy are non-negotiable. When one component wears out or is poorly manufactured, the entire system becomes unbalanced, causing downstream problems such as inefficient combustion, black smoke, hard starts, and injector damage. So, how do you determine if the fuel injection pump you're considering is up to spec? Start with a bench test before even installing the unit. Use a fuel injection test stand or a specialized pressure testing rig that can simulate real-world conditions. You're looking for consistent pressure output at idle, mid-load, and full-load simulation. Watch for pressure drop-offs, pulsation, or surging. These are signs that internal tolerances are compromised. Another step is to perform a visual and mechanical inspection. The mounting surfaces must be perfectly flat. Threaded ports should be clean, undamaged, and aligned. The shaft should spin smoothly with no tight spots or noise. If you hear a grinding or feel resistance, there's likely internal scoring or misalignment. Also, inspect for serial numbers, production markings, and batch codes. A legitimate, OEM quality unit will include this information clearly. Many counterfeit or refurbished units on the market use sanded down surfaces or re-engraved numbers to hide defects or previous usage. Avoid these at all costs. Once a pump passes visual and bench tests, it's time to install. Preparation is critical. Clean all mating surfaces on the engine block. Remove old gasket material thoroughly. Always use new seals or gaskets that match OEM specs. Torque the mounting bolts in a diagonal sequence to distribute pressure evenly across the mounting surface. Over-tightening one side can cause distortion and compromise the seal. Prime the fuel system to eliminate air pockets before startup. Air in a high-pressure system can cause vapor lock, poor spray atomization, and in severe cases, pump cavitation. Ensure the fuel lines are flushed, and the filters replaced prior to installation. Once installed, the engine should idle smoothly, ramp up power without hesitation, and respond linearly to throttle inputs. Observe exhaust color, it should be clean. If there's persistent black smoke, unsteady RPMs, or fuel knock, it could be due to an improperly installed or underperforming injection pump. One tip often overlooked is post-installation data logging. Use a diagnostic tool or scan system to monitor fuel pressure, injection timing, and RPM correlation. These numbers provide a valuable benchmark to compare performance over time and help identify early-stage wear or contamination. Let's move to a common issue: buying from unreliable sources. There's an increasing number of low-quality replicas circulating in the aftermarket. While they might look similar externally, the metallurgy, sealing surfaces, and internal tolerances are usually far below OEM grade standards. These copies often